All right, so this first expansion of logs is about as complicated as you could get. It'll incorporate all the different things that you'd be expected to know how to expand. And so I'll kind of talk through this here real quickly. And remember, any factor that falls in the numerator is going to have a positive log. Any factor that falls in the denominator will have a negative log. And then you can simplify what remains. So if I were expanding this, I'd start in the numerator. Log base 2 of my first factor is 2. Move to my next factor. It's also in the numerator, so it's a plus. Log base 2 of x squared. And move to my next factor, a y. It's also in the numerator, so plus log base 2 of y cubed. Okay, now I move to my next factor. It's in the denominator. So now I'm going to have a negative for my log. So minus log base 2 of 3. My final factor, z, is also in the denominator, so it's going to have a negative in front. Log base 2 of z to the 4th. Okay, so once I expanded these initially, I can go in and apply the properties. So anytime I have a power, I can move it into the coefficient in front of my log. So the 2 gets moved out front. This 3 gets moved out front. This 3 stays. This 4 gets moved out front. And then my final step is to simplify anything. Well, here's a case where I have log base 2 of 2. Anytime the base of my log and the number in my log are exactly the same, it has a value of 1. So I can replace that with a 1 plus 2 log base 2 of x plus 3 log base 2 of y minus log base 2 of 3. There's no simplifying that can occur there. Minus 4 log base 2 of z. And so this would be my expanded form. Yeah, Manu.
How do you determine whether the exponent is in front or stays right?
You'll always just move it in front. If you're, for this one?
Yeah.
Because so now think about it. So this is my, so this, the base of my log is 2, and the number inside is a 3. This would be my power right here. So the power is just a 1. So all of these, do you see how this 3 equates to this z and this y and this x and this 2?
Okay.
It's not the power of anything. Okay. I see that I wrote it. It looks a little bit superscripted a little bit, but it's not. It's inside that log.
Okay.
Okay. Now, really quickly, while I'm talking about this, a reminder of how you enter this online. So if you were entering this whole expression online, it would be 1 plus 2 log. Anytime you have your subscripted base of your log, we're going to use square brackets. So we get, every time we're representing this base 2, we're going to put it in square brackets. So log base 2 of 3 minus 4 log base 2 of z. So subscripted values will be enclosed within square brackets. All right, so that that was similar to what we did in the evaluating without a calculator type material. The reverse process means going from the expanded form back into the condensed form. So writing several logs as a single log, that can be done in the following. Okay? Whatever log is shared by all of the terms, you're going to rewrite this as one single log with that base. So here we're dealing with a natural log, so a log of base e. So when we condense this, it's going to be condensed into one single natural log, ln. Okay, and now we can go in and we can put any factors, any values inside the logs that are positive are factors of the numerator. Any values that are inside a log that has a negative in front of it are factors of the denominator. So as we go through here, the natural log of 12 is positive, so the factor 12 goes in the numerator. This coefficient of 2, we're now going in the reverse process, so that gets moved up to a power. And this x squared has a positive log, so it's a factor of the numerator as well. Okay. This next factor is positive, so the y goes in the numerator. It's a y squared. I left it in that form, so you don't have to change it at all. The y squared simply goes in the numerator. And now our last two factors are the last two terms have negative logs, so those are factors from the denominator. So the natural log of 3 means our factor of 3 goes in the denominator. That's this negative. And then this coefficient of 3 gets moved up to a power. And so this z cubed becomes a factor since it's negative in the denominator. And so our final step here would be to cancel. 3 goes into 12 4 times, and so we get our final answer, the natural log of 4x squared y squared all over z cubed, and that will be our solution.